Hello everybody and welcome to exercise 7. This is the last exercise in our list of final exam review problems. And in this video we're just going to be looking at part A of this exercise. Okay, let's read what this is giving us together here. So we've got a linear transformation T that's going from P2 of R to P2 of R, and they're giving us a basis, okay, for P2 of R consisting of those three polynomials. And notice that they don't give us a direct formula for t. They do give us some information about the function, though. They tell us that there are three polynomials p1, p2, and p3 that we can substitute in that give us 1 plus x squared, 3x squared, and negative 4 plus x out. But the catch is, all we know about those p1, p2, and p3 is that they form a basis, okay, for P2 of R, but we don't know what they are specifically. Okay, so that's kind of what makes this problem challenging. Okay, and another piece of information they give us is this matrix Q. They're telling us that that's the change of coordinate matrix that takes us from beta prime coordinates to beta coordinates. So there's a connection between these two bases through that matrix that we've got. Okay, so part A would like us to use all of that information somehow to figure out what the three polynomials p1, p2, and p3 are in this unknown basis. Okay, how could we do that? Okay, well, really, the only thing that we have to work with is this matrix up here, the Q, a way of kind of transforming between a basis that we don't know, beta prime, and a basis that we do know. So that's the tack that I'm going to take here. Okay, and specifically the connection. Remember what a change of coordinate matrix does. It takes us from beta prime coordinates to beta coordinates. So if we just focus on the problem of finding P1, what we could say is this, that if we take Q and multiply by the beta prime coordinates of P1 of x, what should come out the other side is the beta coordinates of P1. Okay, and the nice thing is if we could figure out what this is over here on the right-hand side, we do know what the basis beta is, so that's going to help us to build this vector P1. Okay, so to get the process started, we need to ask ourselves, what is this vector over here on the left-hand side? It's like asking you, how would you build the polynomial as a combination of the vectors in the basis beta prime? Okay, so it's like asking you to fill in the blanks in this statement. Okay, well, how would we do that? You can probably see that if we put a 1, 0, 0 in those blanks, we get a true statement. And what that demonstrates is that the coordinate vector of P1 relative to the unknown basis has to be these three numbers, basically. 1, 0, 0. Okay, so going back up to this equation then, we now know what the left-hand side is, so let's do that calculation. We'll take the matrix Q, and we will multiply it by this coordinate vector of P1 relative to beta prime. That's 1, 0, 0. You do this multiplication, and you'll discover you're just going to get the first column of the matrix. Okay, what have we just calculated there? Well, we just calculated the right-hand side, which is the coordinate vector of P1 relative to the basis that we do know. And so what's nice about that is it gives us a way to figure out what P1 is very concretely. These three numbers that we see here are just coefficients on the basis beta. So what we're going to get then is negative 1 times 1 plus negative 4 times 1 plus x plus 3 times 1 plus x squared. Okay, and that's a calculation that we can do. You can go through and add those up and confirm that you just get negative 2 minus x plus 3x squared. Okay, so we have just figured out one of the three things that they asked us for. We now know what P1 is. Okay, and to get P2 and P3, we essentially repeat this process. Okay, so notice that P2 is 0P1 plus 1P2 plus 0P3, which tells us that the coordinate vector of P2 relative to the unknown basis is 0, 1, 0. Okay, we're going to take that 0, 1, 0 and multiply it by our matrix. Okay, that's going to give us the second column of the matrix. And remember what that is. That's the coordinate vector of P2 relative to the basis that we do know, and it gives us a way to calculate P2. So P2 is going to be 1 times 1 plus negative 5 times 1 plus x plus 2 times 1 plus x squared. Okay, and again, just do the algebra there, and what you should wind up with is negative 2 minus 3x plus 2x squared. Okay, there's the value of P2. Okay, and you might have noticed a pattern by now. Okay, so to get P3, first step is to take that change of coordinate matrix, multiply it this time by the coordinate of P3 relative to the unknown basis. That's going to be 0, 0, 1, which is going to produce the third column in our matrix. Should be the coordinate vector of P3 relative to beta, and it gives us a way to build P3. Okay, so P3 is going to be 0 times 1 plus 2 times 1 plus x minus 1 times 1 plus x squared. And do the arithmetic, and you're going to get 1 plus x minus x squared out of that. And there's the value of P3.